Welcome back. We started solving this question in the previous video. We completed the table for the relation y is equal to x squared minus 5x plus 3. Then we used the values of x and y in the table to draw the graph of the relation y is equal to x squared minus 5x plus 3 on a graph sheet. In this video, we are going to use the graph of the relation that we drew in the previous video to find I, the truth set of x squared minus 5x plus 3 is equal to 0. I, the least value for the graph of the relation y is equal to x squared minus 5x plus 3. And I, the gradient of the curve at x is equal to minus 1. So let's start with the first one. The truth set of the equation x squared minus 5x plus 3 is equal to 0. So the function that we have drawn on the graph sheet is y is equal to x squared minus 5x plus 3. We can see that we got this equation by equating the function to 0. So if you equate this function to 0, you are going to have the equation x squared minus 5x plus 3 is equal to 0. We have learned how to use the graph of a quadratic function to find the solution of such an equation. In the video on finding the solution of the quadratic equation formed by equating the function to 0, which is the video number 29 in this playlist, we learned that the solution of this equation will be the x-intercepts, that is, the x-coordinates at the point where the curve cuts the x-axis. On this graph, the curve cuts or intercepts the x-axis at this point and this point. So the solution of this quadratic equation will be the x-coordinate here and the x-coordinate here. On my graph sheet, the x-coordinate of this point is 0.7 and the x-coordinate of this point is 4.3. So the solution of this quadratic equation is x is equal to 0.7 or 4.3. But the question said we should write our answer as a truth set. So we will say that from the graph, the truth set of the equation x squared minus 5x plus 3 is equal to 0 is s is such that x is equal to 0.7 or 4.3. Let's go on to the next question. Find the minimum value of y is equal to x squared minus 5x plus 3. We have learned that the minimum value of the function will occur at the turning point. The turning point is the point where the curve turns. So on this graph sheet, the turning point is at this point. This is the point where the curve turns. The minimum value of the function will be the y-coordinate of the turning point. So to find the minimum value of this function, we will first locate the turning point just as we have done here. Then we will trace it to the y-axis to get the y-coordinate. On my graph sheet, the y-coordinate of the turning point here is minus 3.4. So from the graph, the minimum value of the function y is equal to x squared minus 5x plus 3 is minus 3.4. We learned how to do this in the video on using the graph of a quadratic function to find the maximum and minimum value of the function, which is the video number 33 in this playlist. So if you want to refresh your memories on how to use the graph of a quadratic function to find the maximum and minimum value of the function, you can watch the video number 33 in this playlist. Let's go on to the last part of the question, which says that we should find the gradient of the function at x is equal to minus 1. In the video on finding the gradient of the function at a point on the curve, which is the video number 33 in this playlist, we learned that if you want to use the graph of a quadratic function to find the gradient of the function at a point on the curve, the first thing you have to do is to locate that point on the curve. So here we are going to find the gradient at x is equal to minus 1. So we have to locate the point x is equal to minus 1 on the curve. So we will go to the x-axis and we will locate minus 1, which is at this point. We can see that minus 1 does not fall on the curve. So we have to trace it to the curve. So you trace minus 1 to the curve and it will fall on this point. So at this point on the curve, x is equal to minus 1. After you have located the point on the curve, you draw a tangent to the curve through the point. In the video on finding the gradient of the function at a point on a curve, which is the video number 37 in this playlist, we learned that the tangent is a straight line drawn to touch the curve through the point. So the tangent to the curve through this point is the straight line drawn to touch the curve through the point. After you have drawn the tangent to the curve through the point, you will then find the gradient of the tangent. The tangent is a straight line, and we already know how to find the gradient of a straight line. You will choose 2 points that fall on the line and then use the formula gradient is equal to y2 minus y1 divided by x2 minus x1 to find the gradient. So let's do that. I'm going to choose this point here as my first point. Then I'll choose this one as my second point. You have to find the coordinates of these points. So you trace it to the x-axis to get the s-coordinate, which is -2 here. You trace it to the y-axis to get the y-coordinate, which is 16. So the coordinates of this point is -2, 16. You do the same thing here. We can see that this point falls on the y-axis. It means that the s-coordinate is 0. The y-coordinate here is 2. So the coordinates of this point is the s-coordinate, which is 0, and the y-coordinate, which is 2. So we now have 2 points that fall on the tangent, 0, 2, and -2, 16. Using the formula gradient is equal to y2 minus y1 divided by x2 minus x1, we can find the gradient of the tangent. I'm going to use 0, 2 as my x1, y1. Then I'll use -2, 16 as my x2, y2. So we now have x1, y1, x2, y2. You substitute them into this formula to get the gradient of the tangent at the point x is equal to -2. You will have y2, which is 16, minus y1, which is 2, divided by x2, which is -2, minus x1, which is 0. 16 minus 2 divided by -2 minus 0 will give us -7. So it means that the gradient of the tangent to the curve at the point x is equal to -1 is -7. But in the video on using the graph of a quadratic function to find the gradient of the function at a point on the curve, which is the video number 37 in this playlist, we learned that the gradient of a tangent to the curve at a point is the same as the gradient of the function at that point. So the gradient of the tangent to the curve at the point x is equal to -1 is the same as the gradient of the function at the point x is equal to -1. So we can say that from the graph, the gradient of the curve at the point x is equal to -1 is -7. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another likely examination question. Bye bye.